to look at part 2 of the Unit 5 study guide. The first question asks, in which table do the values of x and y reflect a non-proportional relationship? So what I did here, and we've had one like this before, and it may have been very, very similar or the same one. And remember, I worked backwards when I did this, and I'm looking for a non-proportional relationship. So I'm looking for one that doesn't include the point 0, 0, or the origin. So on all of those except for A, those are all proportional. A does not go through the origin. The y-intercept is 7. So A is the correct option, the one that does not pass through the origin. Next one, Marcus ran a 6-mile race in 48 minutes. Which graph has a slope that best represents Marcus's average rate of speed during the race? So he was going 48 minutes per 6 miles, which meant when I divided that, he's running 8 minutes per mile. So on here, I've identified where 8 minutes and 1 mile is. And this one here has the correct rate. This one is just showing 8 minutes to go every mile. So that's pretty interesting there, how you can be at every mile, 0 and 8 minutes, all the way up. So B is the correct one because he starts as proportional, 0 minutes is 0 miles, and then he's going 1 mile in 8 minutes. And again, these ones are way off. All right, which graph below best represents the linear equation y equals 3x plus 6? So you need to remember that the 6 is your y-intercept, and then that's your slope or your rise over your run. And I've got a little note here to make sure you're watching your units on the graphs, because our y-axis is going up by 2s, and our x-axis is going, sorry about that, your x-axis is going up by 1. So I had to identify the y-intercept. So 6, this one can't be correct because it doesn't have the correct y-intercept. This one does. This one does not. And D has the correct y-intercept. So at this point here, I'm looking at B and D. Now I'm going to use my slope or my rise over 1, which is 3 over 1. So we're going to rise 3 and run 1. So from 6, I rose 3 and ran 1. So 9 rose 3, ran 1. And that's on the line there for the graph. Next, I'm going to go to this one. Rise 3, run 1. It's above it. Rise 3, run 1. And it's getting further and further above it as I move along. So your correct answer is B. The graph of a linear function is shown on the coordinate grid. What is the y-intercept of the graph of a linear function? Again, we're looking for where the graph crosses or intersects the y-axis, and that's at -5. So your y-intercept is -5. Which table identifies points on a line produced by the equation y equals -8x minus 3? So we need to work this out by hand until you have calculators. And to do that, I just input these x values in for x. So -8 times 0 minus 3. -8 times 0 is 0, minus 3 is -3. So that one works. This one does not. We don't know about this one because 0 is not on here, so we don't know about this. So at this point right now, A is the only one we know could work so far. Next, I'm going to input 1 for my x. -8 times 1 is -8, minus 3 gives me -11. All right, so at that point, 1 and -11 aren't on there, so that doesn't work. And then 1 and -11 are here, but they're not here. So right now, C is the only option that works. I went through and worked this out with 2 as my x value, just to double check and make sure that this table is going to continue working, and it does. So C was the correct option for that. Jacob earns $25 each day that he works at his uncle's fruit stand, plus a $5 monthly bonus if he arrives at work on time every day. Last month, Jacob was on time every day. Which equation best represents the linear relationship between x, the number of days Jacob worked at the fruit stand last month, and y, the total amount of money he earned last month? So he's getting $25 per day, so that's my slope. And he gets a one-time monthly bonus of $5. So I just input that into my y equals mx plus b, or my slope intercept form, and then I try to find the correct one. Remember, my equation is going to start with a y, so that immediately should tell you that one doesn't work. And then this one right here matches the equation I built. Which graph represents y as a function of x? Remember, it has to pass the vertical line test. So I'm going along here, and my pencil can cross this graph only at one point as I go along there. Here, pretty much as soon as I touch this, I'm going to be crossing that pencil over right here. Boom. It's hitting twice. That fails the vertical line test, not a function. Okay. Same thing here. This straight line here, vertical line touches twice, fails the vertical line test. This, remember when you see this undefined slope, this is telling me I do not, this every single point on top of here, x is repeating for every point. So this is not a function either. This is the only one that is a function where my pencil only crosses the graph at one point as I go across. Which graph shows a non-proportional linear relationship between x and y? So remember, it cannot pass through the origin for non-proportional. That intersects the origin, intersects the origin, intersects the origin. This is the only one that doesn't pass through the origin. B is the correct answer for a non-proportional linear relationship. Which graph shows a proportional relationship between the values of x and the values of y? Again, we have to have a straight line passing through the origin. Here's our straight line passing through the origin. Doesn't pass through the origin. Doesn't pass through the origin. Not a straight line, and it doesn't pass through the origin. Our correct answer for that was A. Which graph shows a proportional relationship between x and y? Doesn't go through the origin. Doesn't go through the origin. Doesn't go through the origin. D is the only one that goes through the origin of the straight line. Answer the following question. The value of y varies directly with x. When y equals 75, x equals 1/2. What is the value of y when x is equal to 2 1/4? So I've converted these to decimals because I think it's a little easier to work with. If you want to work with fractions, just remember how to divide by fractions, and that will give you the same answer. So I set my proportion up as y over x equals y over x. So 75 over 1/2, or 0.5, is equal to y, our unknown, over 2.25. I cross multiplied. 75 times 2.25 is 168.75. 0.5 times y is just 0.5y. So at that point here, this is what I have. 168.75 is equal to 0.5y. Then I need to solve for my y, that unknown, and I need to divide by 0.5 on both sides to do that. I end up with y is equal to, and when I divide that out, I'm going to end up with 337.5, which is the same thing as 337 and 1/2. So A was the correct answer. Another way to look at this is 0.5. That's quite a bit larger, this 2.25, than 0.5. So I'm looking for something that's going to be multiplying 75 multiple times, which shows me that C and D could never be correct. So if you can eliminate two options just out of looking to see if it's reasonable, that gives you a better chance of getting them right. The amount of water a washing machine uses to wash clothing varies directly with the number of loads of clothes. The washing machine uses 28 gallons of water to wash 7 loads of clothes. How many gallons of water will the washing machine use to wash 10 loads of clothes? So I used my rate to determine how much per load, so it's 4 gallons per load. So all I needed to do was multiply 10 times 4 to figure out how many gallons will be used for 10 loads, and that's 40 gallons. Katie sells cookies in bags of half dozen cookies for $6. If the cost varies directly with the number of cookies, which packaging and price is equivalent to Katie's pricing? So first I wanted to see, I had 12 on here. So I knew if 6 is a half a dozen, that's $6. 12 cookies would be $12. And so right here I'm seeing a pattern, 6 and 12. Well, to find out my unit rate, I just divided and I found that one cookie is $1. And the only one where the cookies and the dollars were the same was option C, 20 cookies for $20. Which statement best describes the rate of change for this situation? Okay. So I have the height of water increases 2.5 inches per second. So I have a second, 2.5 inches is right here. So these are going up. If we look, half of 5 is 2.5, 7.5. So this one works. I'm going to check the other ones though. The height of the water increases 5 inches per second, and that's 5 right here. That is not on my graph here. The height of water increases 1 inch per second. So 1 inch is approximately right here. Again, is not on my graph. And the last one, the height of the water increases 20 inches per second. That's way up here. That is not on my graph either. So the correct answer was the height of water increases 2.5 inches per second. Mrs. Garth can ride her bike 3 miles in 15 minutes. Which graph has a slope that best represents the number of miles per minute Mrs. Garth can ride? Here, this is saying that this is not going to work for riding a bike. One, we're not going through the origin. Remember, when we're going somewhere, if we go 0 miles, it's going to be 0 minutes. Or 0 minutes and 0 miles. So first, we're looking for a proportional graph. Okay, this one's proportional. And 15 minutes and 3 miles gives me 5 minutes and 1 mile. I just simplified mine right there. So let's look here. I've got 15 minutes, 3 miles. This one works. And then it goes up. That works. Let's look here. 15 and 3 does not work. 15 and 3. You got to see how those points are not on our graph there. So B was the correct answer for 3 miles in 15 minutes. And you will find that time is generally always going to be on your x-axis. A bottle contains 30 fluid ounces of orange juice and 18 fluid ounces of pineapple juice. Which graph has a slope that best represents the ratio of orange juice to pineapple juice in the bottle? So I noticed that my orange juice was my y and pineapple was my x. So orange juice over pineapple juice. And I've simplified my slope here, and I found that 30 over 18 simplifies to 5/3. So I was looking for a graph that went up 5 over 3. Well, that one doesn't work. Up 5 over 3, that one works. Up 5 over 3, that one does not work. Up 5 over 3, that one does not work. This is the only one that follows our rate of up 5 over 3. Which situation represents a proportional relationship? So I have the cost of purchasing pineapples for $2.05 per pound plus a shipping fee of 8 cents per pound. Notice these per pounds. We're just going to add those, and it's $2.13 per pound. So that's my slope. The cost of purchasing grapefruits is $1.90 per pound with a coupon for $2 off the total cost. So we have something changing off the total cost. That does not work. The cost of purchasing a basket of cucumbers is $1.60 per pound plus a $5.50 fee for the basket. So we're getting an extra fee over those pounds. So that's not proportional either. The cost of purchasing kiwis for $4 per box of that should say kiwis with a delivery charge of $2. So we're having an additional fee there that is not proportional. The only one that's proportional is pineapples. A student released a balloon at ground level and it rises into the air at a constant rate. After 5 seconds, the height of the balloon is 20 feet. The balloon continues to rise at the same rate. Which table shows the relationship between the time in seconds x and the height of the balloon in feet? So we have height over time, right? So height over time, 20 over 5. I simplified it this way just so I could see my rate, and that then I used my seconds here, and it was 10 seconds. So to go from 5 seconds to 10 seconds, I just need to multiply by 2. So then I just need to multiply my height by 2. 20 times 2 is 40. So then I was looking for heights at 40 for time 10 seconds. So that was here and here. Next, I wanted to go to 20 seconds because that was my next option. So 10 times 2 again, and times 2. 40 times 2 is 80. So now I was looking for 20 seconds, 80 feet. And this works. And then this one did not work because that was 60 feet. So B was the correct answer for that one. Which graph represents y as a function of x? Again, we're doing our vertical line test. And so when I ran my pencil, I found, boop, I'm crossing this graph at 2 places. That is not a function. Here, when I get to my line, I'm crossing all of the points. So that's x repeating the entire line. So this is not a function either. Here, as I'm crossing the line, there's a lot of waves, but I'm only ever crossing it at one place with my pencil. That is a function. Next, I have here, and you can see where I've got the pencil, and I'm crossing at 2 places right there. So that is not a function either. C is the correct answer. Which situation could not represent a proportional relationship? So again, we're looking for our y equals mx plus b. We're looking for, because it's not proportional, we're looking to have something additional. So the weight in X weeks of a baby that gains 1 pound per week, if its starting weight is 7 pounds. So we're going to have that 1 per week, but we're going to add that 7 pounds. So that one is not proportional, so that works. Here, the number of gallons of water in X barrels with 38 gallons of water in each barrel. So that's just y equals 38x. The amount an employee who makes $14.50 per hour earns in H hours, again, y equals 14.5x. That's proportional as well. And the cost of purchasing P pounds of bananas for 75 cents per pound, another proportional relationship. I'm not having any additional charges or anything on those. So your correct answer was A. And the last question you had to do was answer how you're going to do on the test for next week, which is going to be tomorrow. So I hope if you have any questions, you come to my meeting and get cleared up on anything that you're missing before tomorrow. Have a great day.